Hello grade 7 learners. This topic is all about addition and subtraction with scientific notation. Here is now the objective. The learner will be able to perform addition and subtraction of numbers in scientific notation. In adding or subtracting numbers in scientific notation, we must always remember that the exponents must be the same or equal. If they're not equal, we need to find ways on how to express it in the same power of 10. Remember that in our previous video tutorial, that numbers in scientific notation is in this form, a times 10 to the power of n, where your a is your first factor and it should be greater than or equal to 1 but less than 10. And this 10 here is a constant and n is our exponent. Let's have this first example. 2.5 times 10 to the power of 5 added by 4.3 times 10 to the power of 5. So our second factor here in this expression, 2.5 times 10 to the power of 5 is 10 to the power of 5. Our exponent here is 5. For this expression, 4.3 times 10 to the power of 5, our second factor is 10 to the power of 5. Still, our exponent is 5. So are they the same? Yes, they are the same. So meaning we will just copy it. So that is 10 to the power of 5. And this first factors here, 2.5 and 4.3, we will just add it. So 2.5 plus 4.3, that is 5 plus 3 is equal to 8. And 2 plus 4 is equal to 6. So that is 6.8 times 10 to the power of 5. So this is now our final answer. Example number 2. 9.8 times 10 to the power of 9 subtracted by 5.3 times 10 to the power of 9. For this expression, our second factor 10 to the power of 9 has an exponent of 9. For this expression, our second factor 10 to the power of 9 has an exponent of 9. Observe that they have the same exponents. So we'll just copy 10 to the power of 9 and we will subtract the first factors, 9.8 minus 5.3. So that is 8 minus 3 equals 5 and 9 minus 5 is equal to 4. So that is 4.5 times 10 to the power of 9. So this is now our answer. Maybe you're now thinking, what if the exponents of your second factors are not the same? What are you going to do? Of course, we'll find ways to make the exponents of our second factors the same. Let's take this example. 2.0 times 10 to the power of 4 added by 5.0 times 10 to the power of 3. So we have here the first scientific notation. You have the second factor, 10 to the power of 4. And the exponent here is 4. Added by 5.0 times 10 to the power of 3. So we have here the second factor here has the exponent of 3. Observe that the exponents are not the same. So we cannot simplify it directly. We need to find ways so that the exponents of the second factors are equal. Remember that when we will move the decimal point to the left or to the right, that will change the exponent of our second factor, which is 10. So our target here it could be we will change this 10 to the power of 4 to 10 to the power of 3 to make it similar, or we can change 10 to the power of 3 to 10 to the power of 4 to make it similar. For our example here, I'll choose to change 5.0 times 10 to the power of 3. And notice that when we get the target of our expression is 4. So the exponent here must be 4. So we must get the bigger number. Therefore, we need to move the decimal point to the left. And how many places? To make 3, what is lacking to make it 4 is 1. So 3 plus 1 is equal to 4. So we will move this one to the left only once. So that's 1, and we'll transfer the decimal point here. So that will make it 0.50 times, so it will make it bigger. So since we move only one place, so that's 3 plus 1 is equal to 4. So this time, we have now similar second factors. 10 to the power of 4 and the other one is 10 to the power of 4. So we can now write it here as our second factor, 10 to the power of 4. And the first factor is 2.0. We will add it to the first factor of the second scientific notation, 0.50. And that is 2.0 times plus 0.5 is equal to 2.5. And copy the second factor, 10 to the power of 4. And that will give us an answer of 2.5 times 10 to the power of 4. Let's have another example. For example number 4, we have 2.0 times 10 to the power of 7 minus 6.3 times 10 to the power of 5. So we have here the first scientific notation, and our second factor is 10 to the power of 7. For the second scientific notation, our second factor is 10 to the power of 5. So for this one, we have 7 as the exponent. And for this one, we have 5 as the exponent. Notice that they have different exponents. So we'll find ways on how to make these second factors equal or the same. We can choose any of the two expressions. As what I have told you, when we move the decimal point to the left or to the right, that will change the power of 10. So for our example, we'll choose the second scientific notation, 6.3 times 10 to the power of 5. So we need to increase this power, which is 5. Therefore, we need to move the decimal point to the left. And how many places? What do we need to get? We will add to 5 to get 7? So 2 places. So we have 5 plus 2 equals 7. So we need to move this decimal point. We have to move it 2 times. So twice. We have 1 and 2. So we'll add 0 here. That's why we have 0.063 times 10 to the power of 7. Why is it 7? Because we move 2 places to the left. So that's 5 plus 2 equals 7. And this time, we have now the same second factors. So we'll just copy it, 10 to the power of 7. And then the first factor is 2.0 minus the second one, which is 0.063. So that's 2.0 minus 0.063 is just equal to 1.937 times, just copy the second factor, 10 to the power of 7. And we have now the answer, which is 1.937 times 10 to the power of 7. Another example. Another example, 5.3 times 10 to the power of negative 9 added by 2.5 times 10 to the power of negative 7. So we have here our first scientific notation has the second factor 10 to the power of negative 9, and our second scientific notation has the second factor 10 to the power of negative 7. So still, they have different exponents. So what are you going to do? We need to rewrite this scientific notation in the sense that the second factors have the same exponent. So in this case, we can choose this first scientific notation. So our target is to make this one negative 7. So it should be bigger. So we will move it to the left. So how many places? So we need to move it 2 places to the left. So we have here 1 and then 2, and we'll add 0, and then we'll put a decimal point. So we have here 0.053 times 10 to the power of negative 7 added by 2.5 times 10 to the power of negative 7. So we have now the same second factors. So we'll just copy it for our final answer. And the rest, the first factors, 0.053 plus 2.5. That will give us the result of 2.553 times 10 to the power of negative 7. And now our answer is this one. For our last example, we have here 5.3 times 10 to the power of 3 minus 4.8 times 10 to the power of 3. So for this case, we have our second factors which are the same. So we can directly write it here for our final answer. But your first factors, you have here 5.3 minus 4.8, since the operation here is subtraction. And that will give us a result of 0.5 times 10 to the power of 3. Remember that a number is written only in scientific notation if it's in the form a times 10 to the power of n, where your a should be greater than or equal to 1 but less than 10. In this case, this is not yet the final scientific notation form because our first factor does not reach to 1. So we need to write this 0.5 in the sense that this one will reach to 1 or can be greater than 1 but will not reach to 10. So we need to move this to the right. In this case, when we move it to the right, the decimal place to the right, the value of our exponent will become smaller. So we'll try to move this one. It's 1. So the decimal point is here. So that 5.0 times 10, we move it only once. So we will subtract 1 from 3. So that's 3 minus 1 is equal to 2. So that's the answer now. 5.0 times 10 to the power of 2. Thank you so much, everyone. And don't forget to subscribe my YouTube channel. Bye-bye.